So different apps are actually requesting for different portion of our private data. So each of them are actually constituting a different profile. So it's something like this, and let's say Facebook, it may ask you for some age, gender, etc. And like for the WebMD and Amazon, they may ask for completely different things. So the problem here is that here, the app gets to define what the profile looks like. And the user just have no choice, but just like blindly give them what they want with no control, which leads to the privacy leakage problem. So to solve this problem, so what do we want to do in our work is to give user the power to have the fine-grained control over their privacy leakage using dynamic profiles. So in our idea, the user gets to define what the profile looks like, and they have some this checkbox, and then what they can do is that they can just decide what to give and what not to give to the apps. So to achieve this, one very important step is to map the profile items to the privacy-related functionality, so that the user can get enough information to know just how to decide the trade-offs between the privacy leakage and the customization. So let's take an example. So we have a profile here, and what it do is like it will map the age and gender to the friend recommendation functionality in an app. For example, in the Facebook, and the location information can be mapped to those, for example, those events updates. Just let you know what are the events happening that are happening like near you. So with this mapping, here are some interesting things that can happen. So the first benefit is that we can prevent those unnecessary private exposure. So for example, here we can see in the app, it does not really use it. So it asks you this carrier information and phone number information, which is actually real for Facebook, but it doesn't really use it for some real functionality. So here, as user, with this dynamic profile, we can just cross them off and decide not to give them out. So the second benefit is that with this dynamic profiles, so the user can decide for themselves how to balance the trade-off between the customization and the privacy exposure. So for example, here, the user used the Facebook app, but what he really wants to do is just to have the friend recommendation to get new friends, but instead he doesn't really interested in those events happening near him. So what he can do is he can just cross the location information off in the profile and just keep the age and gender. So third, what this can do is that the user can give a disjoint set of these profiles to different apps, and this can prevent the data linking problem in Android, for example, through the IPCs. So to achieve all this, and here are some preliminary design and the challenges. So the first is that we need to get the profile spectrum, which means that those input which are used in the app customization. So to achieve this, we can probably use some app level or device level information flow tracking, and also or those network level tracking as Dave was talking about in this morning. And with this, then we need to realize the key step, the mapping between the profile items to the privacy-related functionalities. So one thought to achieve this is that to use the automated UI exploration tool, which is built in our previous IMC work, which can help us know which input triggers what kind of privacy-related APIs. Then after this, we bridge the gap between the API and the privacy-related functionality using the API knowledge base, which is designed and used in another of our previous work. So with all this, then we also need another way to translate the user policy to the profiles, which may not be a perfect one-to-one mapping. And last but not least, then we need to have a runtime framework to help enforce the user policy in the dynamic profiles. And these are actually non-trivial, and we are open for discussion in our poster time. So this concludes the talk, and I guess I can move on.
Great, thanks a lot. So Nick is going to give the second talk.
All All right. Hi, my name is Nikiforakis. I'm an assistant professor at Stony Brook University. The title of my grant is Detecting Accidental Intentional PII Leakage from Modern Web Applications. However, since I only have 5 minutes and I didn't get the 50K grant, I will talk about the motivation of why you would want to do that. Right. So is there a reason to worry about PII leakage? And with my students, we've tried to sort of understand what it means for privacy, what does it mean to have your privacy intruded? And we've come up with this taxonomy that essentially you can see we can sort of separate it into tracking and all the stateful and stateless tracking, third-party cookies, flash cookies, ever cookies, all the stuff that you already heard today. Or it can be about PII leaks, right? And this can be accidental, so it's a website that accidentally leaks your PII as you're giving it to it, or intentional, right? And this is what I want to talk to you about today. So when we're wondering about where is it that we sort of provide our PII on a regular basis, what came to our mind is contact forms, right? So most websites have a contact form. That's the place where you are revealing yourself and you're saying, this is my first name, this is my last name, this is my email, this is my number, this is why I'm contacting you, right? And so that's really the one page where you essentially transit from being anonymous or pseudonymous to being eponymous, right? And so we really wondered what's happening on those contact form pages, right? And the answer, sort of the long form, is available in this paper that we authored with my student Oleksiy and with my colleague Filipa, which will be presented in next year's PETS, and we also have a poster that I can talk to you about. So a sneak peek of the results is that we crawled the top 100,000 Alexa sites, and we really were looking for contact forms and what's happening there. The first result is that 29% of the contact forms discovered, they engage in risky practices, right, that could facilitate PII leakage. And here you see a scatter plot of third-party JavaScript sources on the main page of a website versus the contact form of that website. So everything that is above the y equals x axis means that the Contact Us page had more JavaScript coming from more remote domains than the main page of that website, right? So that's sort of dangerous because you're really trusting all of these remote parties to be giving you code that does not include PII leaking functionalities. The second result was that 2.5% of the forms that we discovered, they leak PII accidentally. This typically means you have a form that is misimplemented, typically using get instead of post. I can tell you about the details. And 6.5% leak PII on purpose. So there is a danger that when you see this 2.5 PII, you're thinking that this is a non-problem, right? Oh, we're just going to fix 2.5% of the web and we're done. And I want to convince you that this is really far from the truth. So let's say that you have this website, this Boston website, I don't know, Joe's Garage, right? And that website has a form, and that form is misimplemented and is leaking your PII. The problem in the current form of the web is that that website is trusting other websites for remote content, like Facebook and Twitter and so on. So what you see here on the graph is that the user can leak his PII on only one website, and all the third parties that accidentally receive it, Facebook, Twitter, DoubleClick, and so on, they can keep on tracking you on the rest of the websites where there was no PII leakage, right? Because you're volunteering PII to them, and they can associate it with the cookies and fingerprint that they already have, right? So one PII leakage is sufficient to keep on tracking you by name on the vast majority of the web, right? That's the takeaway message here. So to conclude, it's often the simple things that get you, right? And we shouldn't forget that next to stateful and stateless PII tracking, we also have PII leakage. And we need solutions to detect and stop PII leakage, nudge, nudge. And this is sort of my closing slide. Here you see this 1993 cartoon. You probably have seen that. 2 dogs discussing, on the internet, nobody knows you're a dog. 2015, the dogs have grown old. Remember when on the internet, nobody knew who we were, right? Thank you for your attention.
Thank you. Just on time. The next talk is given by Ali. Yes.
Okay, hello. My name is Tobias Dehling, and together with Ali Sunyaf, I'm working on a project entitled Toward Transparent Privacy Practices, Facilitating Comparisons of Privacy Policies. So the big picture is that users are concerned about the information privacy, and the providers implement information privacy practices to address those concerns. The problem, however, is that only those information privacy practices that actually are perceived by the users can work towards influencing their behavior. And well, neither theory or practice actually offers currently some feasible approaches to actually make the information privacy practices transparent to the user. So now we have a situation where even the most carefully crafted or user-friendly privacy practices have no real impact because, well, they remain unknown to the user and they are not aware of them. So to illustrate this further, we conducted some empirical research and looked at the privacy policies of ML's apps. And the results were that only 10% of these apps actually had some privacy policy pertaining to the actual app. And they were all very hard to read and had no real useful measures to communicating their content, and also lacked a lot of content and content difference between the privacy policies. So, well, there was actually no transparency of information privacy practices. So to address this issue, we adopted a 4-step research approach. First, we introduced a working definition of transparency of information privacy as an individual's subjective perception of being informed about the relevant information privacy practices of the other party. And this gives rise to 3 key characteristics of transparency tools, which is first, a comprehensive amount of information has to be offered to address the diversity of users in the user base. Then to avoid cognitive overload, there has to be a focus on topical relevance, so there shouldn't be information offered that's just irrelevant for transparency of information privacy practices. And finally, tailorability is required to actually cater to the needs of the individual user. So to identify what are relevant information privacy practices, we started by reviewing the specification of the P3P specification, then conducted the review of the privacy policies of ML's apps to see what's deemed relevant in practice, and we conducted a literature survey to see what's deemed relevant in research. And in future research, we are going to also conduct a user survey to directly incorporate the user perspective into the results. And then we will go ahead and actually develop and test transparency tools. One of them will be the comparison platform for information privacy practices, which should allow users to see what's the difference of privacy practices between interchangeable providers, and also which privacy practices remain unknown for the individual provider. And we'll also go and do some experimental studies to see, to test different approaches for presentation and communication of information privacy practices and see, well, how to best represent the information. So to sum up, at heart, transparency of information privacy practices remains communication issue. Providers have some idea of their information privacy practices and represent their privacy practice in transparency tools, which then serve as a signal to the user base and then gives users some understanding of the information privacy practices. And only if all these links are well crafted and well thought through, it's actually possible to establish transparency of information privacy practices. And how to do that is, well, the purpose of our research. So thank you for our attention, and feel free to contact us by mail or talk about this further in the Q&A.
So for the next talk, we have exceptionally 2 presenters. So this will be presented by Yasemin and Sasha.
Hi, it's nice to be here. We are both usable security researchers from Saarland University in Germany. And we'll give you a brief introduction of a research project we are currently working on, which is on improving the comprehension of browser privacy modes. So we'll give you an idea of what privacy modes are, how a current implementation based on Google Chrome looks like, what the major problem from a usability point of view is, and what challenges for future research are. So, but let's start with what privacy modes are not. We had this announcement last year in December when Google's Eric Schmidt said, well, if you want to protect yourself against the NSA, use Chrome's incognito mode. And no, that's not what privacy modes are for. So what are privacy modes? Privacy modes, or browser privacy modes, promise to not store a browser history when surfing the web. They promise to deny cookies, to not accept cookies when surfing the web. They do not store caches, and they basically delete all local traces when a user closes a browser. So how does that look like for Google Chrome? This is the information dialog users get to see when they use the incognito mode to surf the web. And it basically says, well, in case users read that information dialog, it says, Chrome does not store a browser history. Right now, it does not store cookies. It does not store the search history. So it basically does what privacy modes do. And it explicitly mentions that it does not protect against network attackers. So, well, Eric Schmidt could have known better. Yasemin now will give you a brief idea of what we are actually working on.
So the main problem here for users seems to be comprehension. They don't really know which are the scenarios when to use private browsing modes. And yeah, if they do, what are they being protected from? So what we want to do is build mental models with users to understand what they expect. So we want to identify the threats they see, so who and what they want to protect their data from. We want to see who they think collects their data and how. We want to see what they think, where the data flows. We want to see what users think, how the data is stored and by whom and where and how securely and for how long. And yeah, built based on the models we're going to build. We want to help them understand what actually happens, so kind of to explain the contrast to them, working maybe with browser developers, working maybe purely in research, and we might then be able to help users achieve their privacy goals, kind of close the gap between what they expect and what's actually happening.
Yep.
Okay, thanks. So Bruno Lepris is going to give the next talk on privacy.
Yeah. So then this is the name of the project we proposed. That it's called Privacy. So the idea is try to develop a sensitive evaluator of the information or the photo that are shared online usually. So the motivation is that a lot of people are sharing photos and videos online. So 1.8 billion of photos are shared daily on social media. These images and videos are a lot of personal information, and they can be used for, from a lot of companies. They can be used for advertising, they can be used from insurance company and banks and whatever, but they also raise a lot of privacy challenges. So the idea of our proposal is developing a personal data sensitivity analyzer. So it's a sort of warning filter that make the user aware of the potential personal information that is embedded in the photos they are sharing online. So information like gender, age, lifestyle, personality, and these kind of things. The two research questions we want to investigate is how this information and increasing the people awareness change their decision on sharing or not this information, and also how this awareness affects the monetary value the user assign to their information. The idea came out also from a study that was done 1 year ago, and together with some Telefonica researchers, Nuria Oliver and Rodrigo de Oliveira, and we presented in Ubicon, was the best paper award in Ubicon 2014, where we look at the monetary evaluation assigned by people at information that we can detect from the mobile phone. And what we found is that, in particular, people are really able to understand the information we can infer from location data, but not from media usage or app usage or this kind of things. So here the idea is that if we build a system that help people to increase the awareness of the personal information are sharing, so how change the monetary evaluation? And this is the work plan, so first collecting some data without having any kind of feedback, then implementing a feedback using deep learning technique and computer vision technique to understand things about people. So there are studies, also my study, that show that you can infer personality of people with an accuracy around 80% from the Facebook profile picture. And then having a personal photosensitivity assessment and a second study where we run a user-centric evaluation and we look at the monetary evaluation when we give this risk assessment. The kind of impact for research, this study has impact on different fields, on the idea of personal data market, because it's a way to put ahead the idea of personal data market, increasing the awareness of the people. Also for developing personal data management tools, and also from the side of computer vision and multimedia. There is also a business impact, so the idea is, yes, put ahead this idea of personal data market, where people sharing and sell personal data, but also our methodology could be helpful not only for people, but also for company to understand which kind of information can be inferred from personal photo. So that's it. And so if you have other question, I will happy to answer. Okay.
Sure, thank you. Yes. Our next talk will be on bridging transparency on targeted advertising by Oana from MPI.
Hi, so the main goal of our project is to increase transparency in target advertising by providing users with a tool that allows them to understand why they're being targeted with a particular ad. And we are planning to do this by crowdsourcing the task of transparency to the users themselves. And this project is in very early stage. We don't have things implemented, so if you have feedback, please come and talk with us. So target advertising is everywhere, and probably at some point you were wondering, why are you being targeting with a particular ad? And what do these advertisers know about you? So the goal of our work is exactly to build a tool that answers these two questions. So to explain our approach, let me abstract the ad ecosystem into these three components. So first we have the data that the ad engines are collecting about users that can be online from tracking or can be offline from the data brokers. Then we have the ad engines that takes this data, processes it, and puts users in certain categories. And just note that by these ad engines, I refer to any organizations that is responsible for sending an ad, not just Facebook or not just Twitter, everyone in between. And at the end, we have the ads that are sent to the users. So what we want is to understand what the ad engine knows about users. So one way to do this is to detect and monitor all the inputs and see what the ad engines could learn about users. This would be very cool to have such a tool, but the problem is that to build a tool based on this, we have to monitor very sensitive information from users, like their activities, what size they've been browsing, what have been bought at Macy's. So this makes the deployment very hard. On the other hand, monitoring all the potential data sources that an ad engine has, it's really hard. It might be easier to monitor what users are doing online, but it's very hard to monitor what they are doing offline. So what we propose is that instead to only focus on the output of the systems. And this is nice because it's easy. We don't need to collect sensitive information about users, so we can build this lightweight tool. And the only thing that we have to do now is to see how to infer what the ad engines knows about the users only by using the outputs of the system. So our approach to solve this challenge is to crowdsource the task and ask users to donate the ads that they receive while browsing. And then we can use machine learning techniques on this data and infer what properties a group of users that receive a particular ad have. So more precisely, what do we plan to do? One, we want to instrument an ad blocker to collect the ads the user sees. Second, we would like to collect demographic and interest data from a subsample of users that installed our plugin. So besides the ads that we have, we will also have some more precise information about the users, which can potentially give some very nice insights into the system. And finally, we want to infer the group of properties of users who receive the same ad. For example, in this example, we have an ad, and we have 5 users that receive this ad. And if you have more precise information about these 2 users, we could infer the properties of the whole group of users that receive a particular ad. For this, for example, here we could say that this ad was targeted to female doctors. And of course, we also want to provide a confidence measure in our inference. And we are planning to compute it based on the homogeneity and availability of a property in a particular group and the size of the group. So how our tool would look like? So first, we want users to be able to go over an ad and understand what other users are being targeted with exactly the same ad. For example, here we would have a message like, users who live in France and are between 25 and 35 and are interested in technology also receive this particular ad. And secondly, we would like to have an aggregate view that is based on all the ads that people received along the time and infer what the advertisers could potentially know about them. For example, here, it's like, based on all the ads, the advertiser thinks you are likely a female with 90% confidence, between 20 and 30 years old, and interest in technology with 70% confidence. This is it. Thank you.
And the last and final talk will be given by Ahmed.
Hi, I'm Haddadi from University of London. I know I'm the last thing between you and coffee, so I'll keep this brief, as Augustine says, just a few UK-style slides. So, so we're here, most of the discussions today have been about putting the person at the heart of this whole personal data ecosystem. So we've heard a bunch of tools, a bunch of measurement platforms. So what we are getting really better at is to make the whole personal data space more legible for the individual, so they can start getting an idea about what data is collected about them, where is it going, who is it shared by, and we've had quite a bit of tools today. Also, we've heard about a bunch of tools that are starting to kind of give the user a little bit of control over, can I stop the leakage? Can I actually find out who's getting what data from me? So being systems people, the next natural step that we want to take is actually enable a bit of negotiation between the different parties involved in this ecosystem. So Google and Facebook is not full of really evil bad guys. They are running a business as well, so they are part of this ecosystem. There's EFF, there's Mozilla, there's a bunch of different parties involved in this ecosystem. So can we actually enable a system that enables us to take part in this data dialogue? And the seed of this idea actually came last year, this time, when we were sitting at the back of Churchill College with Paul, actually. And we were discussing that can we take the research a little bit further and provide a way of giving individuals a way to understand the data that is out there about them, and actually being able to run analytics, more complicated analytics services than it is today, right? For example, if, let's say, for the sake of example, I can index, and this is not a data silo, so data is not being collected in the box. The idea is that I just have an index of what data is out there about me. And if I can bring all of these indexes in this box, in this magical box, which we are actually building as a hardware platform. Because not only your personal data should go in it, the data from your household, let's say your IoT devices, your family, the data that you share with the family can go in it as well. So the form that we are building it is like a home router, part of kind of an ongoing part of a new project. Can I index all this data and run third-party analytics, enable third-party apps, and enable things that I couldn't do today just by having a bit of my data in Facebook, a bit of data in Instagram, a bit of data in Google, so I can see some physical activity data in Fitbit, some social media data in Instagram, and do all of this with privacy in mind. But if you're thinking already about homomorphic encryption and differential privacy, you're actually overthinking this. This should be a little bit behind, so one step lower than that. So we are actually working with quite a few HCI people are involved in this, in the ways that can we make this accessible to the average individual in the society, that they can really download an app on this system, let 2 or 3 really irrelevant correlations or analytics run, and use this as a service. So how does it improve the current status? It lets you really try to negotiate that, okay, this is the data that I'm happy to give away, this is the data that I don't want to give away, and if somebody can run a service that can actually come and run at a unikernel, like as a virtual machine on your own data box, fine, you pay for that app, the app gets installed on your device, accesses those pieces of data, does the analytics, gives you the final answer, and it just vanishes. The whole virtual machine vanishes, so nothing leaks back. But maybe you can pay for that service. So we don't need to think always about stopping data. We can sometimes think about, okay, maybe there's the Cambridge way of thinking that distributed is the way to go, but there you go. So lots of things to think about. There's a little bit of a paper that you can have a look, but there's a lot of problems to solve in this space that I'd be happy to talk to you at the poster session, which follows right now. Thank you very much.
Okay, thank you for your attention. So this is it. Now you've seen all the DTL 2015 project that were selected. I just want to have one word of conclusion that tomorrow, well, first of all, we are really looking forward to new proposal for next year based on this research, and most of them are work in progress. Also, tomorrow at 11:45, at the end of the conference, we are encouraging you to come and present opportunities. If you have a data set or a particular problem, an opportunity for funding or anything that could be useful to other researchers. So keep that in mind, and let's start the poster session. The poster will be available right now. They will be at, you have to be back at 5 to 4 for the panel, so in about a little less than 20 minutes, but the poster will stay also afterwards, so you can have a chance to browse multiple ones.